Good morning to one and all. Today we are going to see about the power flow analysis by using the fast decoupled method. Already, as we have seen about the Gauss-Seidel method and as well as Newton-Raphson method. The difference between Gauss-Seidel method, Newton-Raphson method, and fast decoupled method we'll see at the next class, last class, so that you can understand easily after after the algorithm of each and every method, then you can able to compare all this algorithm easy. So here, this coming to the algorithm of fast decoupled method, it is very similar. Actually, fast is one of the improved methods. Which is based on the simplification of Newton-Raphson method, and this method is due to this method and due to its calculation simplification, and also it has fast convergence when compared to Gauss-Seidel method and as well as Newton-Raphson method, and also it shows the reliable results, which becomes more used method in the load flow analysis. So this method is more wide method in the load flow analysis problem. Next, however, this fast decoupled method for some cases with a high RX R by X ratio. Say, for example, resistance by impedance loading is heavy for some times. That is for low voltages, some buses present. It does not convergence well. Sometimes it does not convergence well. Why? Because due to this RX ratios, sometimes the convergence may not comes with. For these cases, many efforts and developments have been made to overcome this convergence obstacles, and some of them targeted the convergence of this RX ratios and others with the low bus voltages. Efforts and elaborations have been achieved in order to improve this fast decoupled method. This method still attract many researchers, especially when computer simulations, mainly this methods used mainly in the computer simulations, and also becoming more developed, and now be able to handle and analyze large size systems. This the attention was focused on the update of voltage angle and voltage magnitude in each iteration based on the improvements of this flops are achieved, and also obviously on the results obtained. The results of these improvements and the comparative analysis, the Newton-Raphson and this classical fast decoupled method. Okay, so known it's okay. It is known for and well known for usage when going for fast convergence characteristics. So these are the algorithm steps. First, step number one, we need to start the program. Next, step number two, formulate the Y-bus matrix. So we need to formulate the first step is to formulate the Y-bus matrix. The Y-bus matrix formulation already we have seen in our previous classes. If not, you go back to my previous classes. So formulation of Y-bus matrix, it is very common for all the load flow solution. First step is to formulate the Y-bus matrix. Next, then compute the bus susceptance matrix. Bus susceptance matrix B dash and B double dash. So here it is susceptance matrix, whereas in the previous algorithm, the fast decoupled method, it is Jacobian matrix. We need to formulate the Jacobian matrix, whereas here we need to formulate the susceptance matrix. Next, what is the step number three? Assume the flat start. Assume the flat start for the voltage solution. So flat start already you know V10 V10 is equal to 1.0 plus J0 or 1 at the angle of 0 degree. That that is delta we are taking as 0 for I is equal to 1 to n for all buses except the slack buses. For all buses except the slack buses, we are starting with the flat start. That is VA is equal to, first we need to after the flat start we need to calculate VA is equal to VA specified value. VA is equal to VA specified value for all the PV buses and the slack buses. Next, step number 4. For load buses, calculate the PA calculated and QA calculated value. What is the formula for doing the PA calculated? Summation J is equal to 1 to N BI modulus Yij into Vj cos of theta ij plus delta j minus delta I. Next, what is QA calculated? QA calculated is equal to minus of summation J is equal to 1 to N Bi Yij into Vj cos of theta ij plus delta j minus delta I. This also already we have seen in our Newton-Raphson method, same formula. So first, this thing, in this step, we need to calculate PA calculated and QA calculated value. The formula for PA calculated and QA calculated are as follows. So this is the formula for calculating the PA calculated and QA calculated. This step you need to remember. Okay. So here, next thing is that step number 5. Step number 5. Sorry, here a small mistake. So QA calculator is equal to, here not cos, it is sine. Okay, so here sine of minus summation J is equal to 1 to N VA Yij into Vj sine of theta ij plus delta j minus delta I. This you need to rectify it. Next, step number 5. For step number 5, for PV buses, check for the Q limit violations. So you need to check the Q limit violations, that is reactive power limit violations. Same like that, what we did in our economic load dispatch problem. So QI calculated less than QI minimum, you need to set the QI specified as QI minimum value. If QI calculated is greater than QI maximum, then you need to set the QI specified is equal to QI maximum. For PV buses will act as a PQ buses. These two things is similar for all the algorithms. Fast decoupled method also, we are checking this Q limit violation, that is reactive power limit violation, that is QA calculated is less than same thing. You need to this step we will call as set the reactive power limits to its minimum and maximum operating limits, that is specified values. Okay, set the reactive power limits to its minimum and maximum limits. If correspondingly, if it is violates the minimum limits, you need to set the QI specified values to its QI minimum. Then if it is greater than QI calculated is greater than QI minimum, you need to set the QI specified is equal to QI maximum. For PV buses will act as a PQ buses. Next, you need to calculate PA calculated, QA calculated. That already we have seen. Next, step number 6. Compute the mismatch vector. Mismatch vector same. Del PA is equal to PA specified minus PA calculated value. Similarly, del QA is equal to QA specified minus QA calculated value. Next, step number 7. Step number 7, we need to compute del PA specified value is equal to maximum of del PA. That is for I is equal to 1 to N except for this slack bus. Next, we need to calculate del QA specified value. Del QA specified value is equal to maximum of del QA. That is for I is equal to m plus 1 up to n. So this thing you need to calculate. This is common for Newton-Raphson method also. Next, from here only this algorithm changes. Up to step number 7, it is common for Newton-Raphson method. Here, we need to calculate the susceptance matrix. Instead of Jacobian matrix, we are calculating the susceptance matrix. So calculate the susceptance matrix B dash and B double dash. So this is the extra step in this algorithm, B dash and B double dash. Next, step number 9. Calculate the del, that is phase angle values, and del V. Del V, we need to calculate del V, that is change in the voltage value. So what is the formula for calculating del I is equal to minus B dash, that is susceptance matrix, the whole inverse, into del PI divided by BI. Next, what is the formula for calculating del VA? That is change in the voltage is nothing but minus B double dash, the whole inverse, del QA divided by VA. This is the formula for calculating del and del V. That is change in the phase angle and as well as change in the voltage. Next, step number 10. Update the state correction vector. Similarly, we have seen in the Newton-Raphson method. What is the formula for calculating the state correction vector? V nu is equal to V volt plus del V. V nu is equal to V volt plus del V. This del V is nothing but change in the voltage. Next, what is del nu? Del nu, that is phase angle nu is equal to phase angle volt plus del. So this is also similar to the Newton-Raphson method. And this step also, like a tolerance limit also same in the Newton-Raphson method, same step. The procedure is continued until del P is less than zeta and del QA is less than zeta. So zeta is the that is a tolerance limit. Okay. Otherwise, if you not specify this tolerance limit, your program will run for n times. Your program will not stop. It will keep on running until you stop the program. So if you give the tolerance limit, automatically the program will stop. If it compass the limit, compass this limit, that is a del PA value, and with the tolerance limit, if it is less than, this program will stop. Otherwise, the program will run for n times. Otherwise, next, this procedure is continued until the you need to check this tolerance limit. Otherwise, go to the step 3. If it is not satisfied, again you need to go to the step 3 and you need to repeat the same thing. Again, you need to repeat the same thing. Okay, we need to calculate PA calculator, QA calculator. Again, we need to check for the limits, reactive power limits. Again, we need to calculate PA, del PA, change in the real power, change in the reactive power, and a specified value you need to calculate. Next, you need to calculate the susceptance matrix. Again, you need to calculate the change in the phase angle value, change in the voltage value. Then similarly, you need to continue the same. Next, you need to update the state correction vector. So what is the state correction vector? So V nu is equal to V volt plus del V, and del nu is equal to del V. So this steps you need to repeat if the tolerance limit not satisfied. Otherwise you need to stop the program. That is the step number 12. So similarly, you can easily program this algorithm, all the algorithm with the MATLAB or Python programming, which is convenient to you, or C programming also, C++ programming also, which is very convenient to you. You can program this logic in any platform. It is not only MATLAB, it is not only for Python programming, whichever the known platform for you, which is very easy for you, you can easily program this algorithm. So this algorithm is very simple. It is very similar to Newton-Raphson method. If you study Newton-Raphson method, this method you no need to study. Only thing is that you are adding the susceptance matrix here instead of Jacobian matrix there. And rest are all same. And also this method combines both the Gauss-Seidel method and Newton-Raphson method. The limitations from Gauss-Seidel method and Newton-Raphson methods are overcome in this algorithm. So it is named as fast decoupled method. So that is one of the advantage of this Newton like a fast decoupled method. Sometimes if this question is asked in your 16-mark question or 10-mark question, so how they will ask means they will ask the algorithm and as well as the flow chart. You need to explain the algorithm and as well as the flow chart. So that's why I'm explaining the flow chart also. So here the flow chart goes like this. First, you need to start the algorithm. Next step is you need to read all the data, line data, bus data, what are the line data, what are the bus data, and all, and the tolerance limit for this P and Q limits, del P and del Q limits. That also you need to read the data. Next, second step is to compute the Y bus formulation matrix. Okay, so that algorithm, that small steps, that also you program in this. Next, find the bus susceptance matrix. So first itself, you can easily find out the bus susceptance matrix B dash and B double dash. Okay, so you need to calculate the susceptance matrix and you need to what do you call? You need to make the derivative, first derivative, and you need to make the second derivative. First, that is B dash is the first derivative and B double dash is the second derivative for the susceptance matrix. Next, initialize the voltage state correction vector. Voltage state correction vector na initialized value. What is the initialized value? That is the flat start. That is V is equal to 1 plus J 0. That you need to initialize the state correction vector. That is how they said. State correction vector you need to initialize. Next, you need to set the iteration count. Iteration is equal to 1. Next, you need to select the bus number 1. Okay, and for the incremental bus, you need to calculate the PI and QI calculated value. PI and QI calculated value. What is the formula? The formula for PI calculated value is PI calculated is equal to summation J is equal to 1 to N Vi vector into Yij, that is the matrix vector, into Vj cosine of theta ij plus delta j minus delta I. Next, QA calculate is equal to minus of summation J is equal to 1 to N Vi into Yij into Vj sine of theta ij plus delta j minus delta j minus delta I. So here it is sine, here it is cos. Real power means cos and reactive power means sine. So in the algorithm, this we made a mistake. This you correct in the algorithm also. Here it is sine. Reactive power means always sine here. Next, we need to check whether I refers to PV bus or not. Then you need to calculate the del PA value. Del PA value is equal to PA specified minus PA calculated value. So it is very similar to your Newton-Raphson method. Next, you need to check for the limits, that is reactive power limits. If QI specified value is less than is equal to QI maximum value. Okay, so you need to what you need to do is you need to check the limits and you need to fix the reactive power limits to its maximum and minimum limits, as we did in our economic load dispatch problem. That is, if it is less than, if it is greater than QI maximum value, you need to set the specified value, QI specified value to its maximum operating limits. If QI specified value is less than minimum value, QI minimum value, you need to set the QI specified value to its minimum operating limits. That you need to calculate. Next, you need to calculate the del QA, that is change in the reactive power limits, that is PI specified minus PI calculated. Similarly, for if it is for a minimum value, similarly you need to calculate del QA, that is specified value minus calculated value. So in general, you need to calculate for real power also. Okay, so this C comes from here. Okay, this C comes from here. So real power also you need to calculate. That is a del PA is equal to del PA specified minus PA calculated value. That is del QA is equal to QA specified minus QA calculated value. And for minimum value, you need to calculate a different that is change in the reactive power. And for maximum value also, you need to calculate the change in the reactive power. The same formula only, but you need to calculate, okay, correctly for minimum and maximum value. Next step, if I is less than n, that is the number of buses, then you need to calculate the change in the phase angle value. That is del I. Okay, del I is equal to minus of B dash in the inverse, whole inverse. This matrix you need to take whole inverse into del PI divided by BI. In next step, del VA is equal to minus of B double dash the whole inverse del QA divided by VA. In some books, this del PI divided by VA will not come. This VA will not be specified. Why it is not specified? Because this VA we are taking as flat start, that is 1 plus J0. So even though anything by 1 is the same answer will come. So that's why in some books it will be not specified, but this is the general formulation. After that, whatever is there, you substitute. Okay, sometimes flat start we need to start. Sometimes in the problem itself, it will be specified. So in that value you need to take. So in some materials or some algorithms, this value will not be specified. Don't confuse. Okay, so this is the general formulation. So that one is default. So there they will not use this VA, del VA. So that you need to understand clearly. Okay, so this also correct, that also correct. But you need to write in generalized, whenever generalized you are writing the algorithm, you need to specify. After that, here you need to write since PA is equal to flat start. So this becomes 1. Like that also you can write. But this is the general formulation. This you need to specify clearly while writing this algorithm. Next, update the bus voltage. That is V nu is equal to V volt plus del V, and also del nu is equal to del volt plus del. So that you need to update. That is, we need to calculate the new voltage and as well as new phase angle. You need to calculate. Next, check for the tolerance limit. As we did it in our Newton-Raphson method, we need to check the tolerance limit. That is, del PA is less than delta and del QA is less than what do you call epsilon. Epsilon. Okay, that is the tolerance limit. That is generally will take as 0.001, and it is user defined. It is not mandatory like you have to take 0.001. So you can also choose your own values, but the program should stop. Okay, so with that you need to select, because the del PA value, based on the del PA value and the del QA value, you need to select the tolerance limit. But generally, if you choose 0.001, it will stop. And also you can select based on your that values. Next step, you need to calculate the, if yes means if yes means you need to calculate the line flow, calculate the line flows and the slack bus power total. You need to display this all these things, total line losses, reactive power generated at the buses. Okay, if no, again you need sorry, if yes, again you need to iterate. You need to go for the second iteration. Iteration is equal to I. So iteration, say for example, if you specify the iteration value as 3, so you need to go for next iteration, or otherwise you need to display all the values. You need to display the line flow limits, line flows, and the slack bus the losses, reactive power generated. Everything you need to display, and you need to print the result, and you need to stop the algorithm. This is the algorithm for Newton-Raphson method. So definitely, sorry, this algorithm for fast decoupled method. Definitely, this algorithm and as well as your flow chart. Flow chart, they will be asking in your 10-mark question if it is asked in the big question. As a 10-mark question, definitely they will ask with the flow chart also and with the algorithm also, because algorithm is very simple. So with the flow chart means what? Just whatever the algorithm you studied in the simplified manner. That's all. But you need to explain each and everything how it is going. Like it is very simple. Easily you can get a full marks in this fast decoupled method. That is 10 marks.